Hello students, welcome to Gyan Lectures powered by Visual Technologies. I am Saptarshi, your electronic mentor, and in this segment of wireless communication, today our discussion will be on PAPR or peak to average power ratio. But to understand this topic, we need to properly have the concept of waveDAM or orthogonal frequency division multiple access. So at first, let's take a quick recap to orthogonal frequency division multiple access. We already know that the waveDAM can be described as a spectrally efficient digital modulation scheme that employs multiple carriers which are mutually orthogonal to each other over a given time interval. Each carrier consists of a pair of sine and cosine wave, relatively known as subcarriers. Now let's consider an waveDAM scheme with n number of subcarriers. The usable transmission bandwidth is equally distributed among the n subcarriers, and if W Hz is the available single-sided transmission bandwidth, then the allocated bandwidth to each subcarrier is W by n Hz. Now let's talk about the channel spacing in waveDAM systems. The difference between two nearby subcarriers is known as the subcarrier spacing. Each subcarrier upon data modulation is often can be categorized as a narrowband modulated signal, but the overall waveDAM signal is a wideband signal for a large value of n. The modulation operation is carried out at the baseband level, and the baseband modulated signal is transposed in the frequency domain by frequency up conversion to the required radio frequency band. Now that is all about waveDAM that we need to know, and now let's discuss about the peak average to power ratio or PAPR. Now the PAPR is the relation between the maximum power of a simple given waveDAM transmitter symbol divided by the average power of that waveDAM symbol. In simple terms, PAPR is a ratio of peak power to average power of a signal. It is expressed in the units of dB. Now PAPR occurs when a multicarrier system is different subcarriers out of the phase with each other. At each instant, they are different with respect to each other at different phase values. When all the points achieve the maximum values simultaneously, this will cause the output envelope to suddenly shoot up, which cause a peak in the output envelope. Now, due to the presence of the large number of independently modulated subcarriers in waveDAM system, the peak value of the system can be very high as compared to the average of the whole system. This ratio of the peak to average power value is termed as peak to average power ratio or PAPR. In LTE system, waveDAM signal PAPR is approx 12 dB. Now, let's discuss about how large PAPR affects the power amplifier. Now, let's start with an example and suppose the desired average output power from the power amplifier PA is 20 dBm. That is also we can calculate as 10 watts. And PAPR of that system is 12 dB. Then in that case, PA device is chosen such that the saturation point of that PA shall be 40 dBm plus 12 dBm, that is equals to 52 dBm or 158 watts. It means that after selecting PA device of saturation power 52 dBm, we operate that the PA at 40 dBm output power, keeping 12 dB headroom for the peak power. And the operating a such large backoff decrease the efficiency of that PA, and as well as know that PA is the most power consumption unit or the power amplifier that is the most power consuming unit in the base station. So it reminds that the what remedies that are need to be taken to reduce the PAPR of that waveDAM signal so that the smaller power amplifier device could be used in that system. Now we will discuss about the trace factor reduction or CFR. CFR is a technique used to reduce the PAPR or peak to average power ratio of the transmitted signal so that the power amplifier can operate more efficiently. In practice, there are different CFR algorithms: clipping and filtering, peak windowing and peak cancellation, etc. Generally, after using CFR algorithm, PAPR is reduced to 7.5 to 12 dB. And that is all about peak to average ratio power or PAPR. And we have learned a recap to FDM systems, peak average to power ratio or PAPR, how large PAPR affects the power amplifier, and the crest factor reduction or CFR. We will continue our discussion on the topic of wireless communication in our next videos. Until then, stay tuned to Gyanon for more informative engineering lectures. Thank you and goodbye.